Everyone, just a quick reminder that we are recording the session. Okay, and Tony, we'll let you kind of be the scribe again as far as making sure that everything looks good and everything.
Yep, looks great, Joe.
All right. How do you like that? You didn't know you was the scribe, did you?
I know, that's a lot of pressure.
It is a lot of pressure. Okay. All right, so we should see that front screen, Tony. It
Yep.
says HMH7 SEER heat pump overview with air handlers. Is that correct?
Yes, good to go.
All right, team. So just a quick reminder one more time as we take a look at the product on the all the way right-hand side, that little single fan unit, that's going to be a 2 and 3 ton model. They're the single fan models. And then the 2 fan models are going to be the 4 and 5 ton units. Now, as a fast reminder also, we need to remember that the service unit fittings themselves, where you hook your service gauges, they're a 5/16 flare. And so we're going to need some of these adapters. Contractors are going to want to make sure and have these adapters on their truck so they can go from that 5/16 flare down to a 1/4 inch service hose flare fitting as you take a look at that adapter. So it's 5/16 on the female end, 1/4 inch male on the other for your service hoses. Now, one thing I always like to mention whenever we do this training, on top of everything else, is the fact that these units are not mini splits. Now, they look like mini splits. They have kind of a similar cabinet look and so on, and they even have a similar technology as far as the compressor modulating from 35 to 100% capacity. So we have some modulating capability on the outdoor unit, even though it's very, very simple to wire up and it's designed to hook up to just a standard air handler with a standard expansion valve on the indoor coil. So I just want to stress that one more time. Even though it has a similar look, these are not mini splits, and we're going to hook them up just like a regular heat pump with just a suction line. We're going to insulate that suction line like we always do, and we're going to have probably about a 3/8 liquid line typically. So just a regular heat pump. The other thing that I really, really like about these, the fact that it's modulating, gives you lots of comfort, but also we've got some nice long line length applications. And so depending on the tonnage, we can actually go up to like 260 feet in some applications. I think the 2 ton model maybe has the limitation of maybe 160 feet or maybe 180 feet. The other thing about a piping application, if you do have a very, very high vertical, after about 16 to 20 feet, you're going to be doing some oil traps in the suction line every 16 feet, but that's all well explained in the install information. So please look at the install information, especially if you've got a real high vertical lift where the outdoor unit is going to be above the indoor unit. You're going to have some oil traps in that suction line. If the condenser is on the roof and 3 stories down, we'll say is the air handler. So please keep that in the back of your mind. If you have a high lift application where the outdoor unit is on the roof and the evaporator is below that. Another thing we like to talk a little bit about is we get a lot of questions concerning what's the capacity of the unit at different temperatures. Now, even though the AHRI rating on these units is at 47 degrees Fahrenheit outside in the heating mode and 17 degrees outside in the heating mode, we have a lot of flexibility here. As a matter of fact, Tony's got some real neat information he can share with you at a later time that shows that these units, even at 0 degrees, they're still making about 25 to 40% capacity. And at 47 degrees outside, they're making just about 100% capacity, real close to it. So they're very, very flexible as far as temperature ranges and lots of capacity. Now, this is going to be important, especially in a straight cool application. As you take a look at the air temperatures minimum and maximum, we see that in a straight cooling application, the maximum would be 122 degrees outside, and the maximum wet bulb cooling on the indoor coil will be 72 degree wet bulb. And in the heating mode of operation, you've got some other parameters as well. So be sure and reference those in your local area as far as min and max outdoor air temperatures for the outdoor coil as well as the indoor coil. Any questions or comments so far on those little highlights on the product before we jump into the technical part of it? Everybody good?
I think that maximum of 122 is important.
I think so.
Certainly you'll have applications in the deep south where, you're gonna hit that. So I think that's a real good feature for the unit.
Absolutely. And the only place that we start getting into a little bit of trouble with that is way out in the desert Southwest, Arizona, New Mexico, southern Nevada, where they see 125, 130 degree ambient temperatures, and then high altitude on top of that, so the air is really thin, trying to pull that thin air across those fans outside, and real high temperature, like I said. So the only place we've had any issues at all, or any not degrading but derating issues, have been in the Southwest, the desert Southwest, as I mentioned, where we have those really high desert temperatures and altitudes that we have to contend with. Good. Okay, well, at this time, fellas, let's go ahead and jump into the heat pump with the AE air handler. Now, one of the things we're going to be stressing today, we're going to be talking about the application of this product with the AE and the variable speed air handler only product. And we're going to have some simplified block wiring diagrams we're going to be talking about and going over. Now, we're going to recommend that on the AE air handler that we utilize that kit number HMH7AK001 for convenience and the supplied parts. Now, it should be noted, in a pinch, if you've got the 002 relay kit, you can still use that kit. However, the RV relay will not be needed for this particular application. And kind of write this down or make a little note of it. That HMH7AK002 kit is required for the variable speed air handler, but it is not required for this air handler. But you could use it in a pinch because you just end up having an extra relay on the board. So the kit number 001 is actually recommended for this application. But let's say you get into a situation for some reason or another, you can't get the kit, or you're out of the kit, whatnot, or you're stuck putting this thing in. Absolutely not. All you can do at this point is very, very simple. Just take a single pole double throw relay, like a little peanut relay, as long as it's got 24-volt coil, and single pole double throw action on the contacts, and then supply your own bi-flow filter dryer. So you can make up your own 001 kit, is what I'm trying to say, very easily. Just make sure you have a bi-flow filter dryer. And we're going to recommend, by the way, while I'm thinking about that bi-flow filter dryer, even in a straight cooling application, please put a bi-flow filter dryer on there, because the compressor has the capability of going into different modes. Even though it's been in the cooling mode, what it will do sometimes, it'll go ahead and put it in the heating mode of operation to exercise that reversing valve. Even if we're not using it, it's going to exercise that reversing valve, put it in reverse operation, for just 30 seconds or whatever, as well as returning oil back to the compressor. Sometimes it'll reverse cycle like that, just to make sure we have good oil return. So even though it's a straight cool application, be sure and still put a bi-flow filter dryer on that liquid line on the unit, because it's a heat pump. In addition, if the contractor later on, or if the homeowner later on wants to convert it to a heat pump, you've already got that bi-flow filter dryer in the refrigeration circuit, and you don't have to open the circuit back up to replace it with a bi-flow dryer. So we always recommend bi-flow filter dryer, and then the relay kit, as we talked about, because of convenience and supplied parts. Finally, we want to make sure our heat pump thermostat has a BO selection, because that B is going to be energized for reversing valve in the heating mode. Now, it's exactly opposite of the rest of our Champion product. We energize on our other heat pump products in the O terminal for cooling mode, but this HMH7, we energize the B terminal for the heating mode. It's not bad, it's just different. We need to keep that in perspective and make sure that our heat pump thermostat has a BO selection, so we can select that B terminal for heating operation. Any questions or comments before we start jumping into some block diagrams at this time? Is everybody good?
Hey, Joel.
Yes, sir.
Do you have to use a heat pump thermostat, even if you're wiring in a straight cool? Just use a heat pump thermostat?
I absolutely love that question. The answer is no, you do not. And so if you are, we'll cover the heat pump application, using the BO selection, but kind of put that in your back pocket. that if you're not going to take a B terminal out there and you're not going to take a W terminal out there, then at that point, you could use just a straight cool thermostat. That is correct. Good question. But I still want you to put that bi-flow filter dryer on there, because the outdoor unit makes some decisions sometimes to switch that reversing valve to exercise it and so on. So we still want that bi-flow filter dryer on there just for safety, so we don't have a high pressure cutout, if it goes into heat pump, just for 30 seconds, just to, make sure that valve's working and stuff, because the outdoor unit will do that. Good question. Okay, so in a heat pump application with an AE air handler, the whole enchilada, that B terminal is going to go outside to energize the reversing valve in the heating mode of operation, as we mentioned. The W2 will be our second stage auxiliary heat. Our W1 will be our first stage auxiliary heat. Now on a heat pump application, we're going to make sure and bring that W wire from the outdoor back inside as well, so that we can bring the heat strip on during defrost, because we want to make sure that when we go into defrost that we don't freeze the homeowner out. Because remember, team, when the unit goes into defrost, it's actually going into the air conditioning mode. And so if we have a heat pump out there and it goes into defrost, we want to make sure and we have some auxiliary heat on as well. The Y terminal is going to go straight outside. The C terminal will tie in to the air handler and then go outside as well. That'll go all the way through. And then the R terminal is our 24-volt hot, powering up the thermostat. But please remember, the R terminal does not go outside on this product, because the outdoor unit has its own power and all that kind of stuff, and it's just receiving signals from the indoor unit and thermostat. It does not require the R terminal to go outside. The G terminal is going to be our fan, and typically on the ECM air handler, on the AE air handler, with that ECM motor, typically G will be selected for the lowest speed tap. And the reason we recommend that is so if the homeowner has some indoor air quality devices, let's say they have an electronic air cleaner or some media filters that they want to circulate the air in the home all the time. If we put G on the lowest tap, so if they go to the thermostat subbase assembly and they call for fan only operation just to circulate the air, we want that air at the lowest airflow possible. That way it's nice and quiet and comfortable. And in addition, it makes the filtration systems work better. So G is typically going to be the lowest speed tap on the ECM motor. Now, if we take a look at that airflow reduction relay, the B terminal, or one side of the relay coil, is going to go up to the S1 outside. And what that's going to do, that's going to allow us to reduce airflow when the outdoor unit is at a lower point of modulation. The other side of that single pole double throw relay, the coil is going to go to 24-volt common to complete that coil circuit. C, or the common of the switching terminals themselves, will tie into your yellow wire going outside for your compressor call. So anytime we're calling for compressor operation, we're going to energize or have power on that common switching terminal or that relay point, that relay terminal point. One of the things we always want to remember too on a heat pump application, if we do have heat strips, or even if it's a straight cooling application, and we're going to have a heat strip in the air handler, even straight cooling, we're going to want to take W1 from the heat strip or that auxiliary heat call and take it to the high speed motor tap on the ECM motor. This is important because when we, even on a straight cooling application on the air handler, when we go into the heating mode of operation, we want to make sure we don't overheat that heat strip or overheat that heater kit. And so we want to make sure and select W1 for auxiliary heat is typical how we're going to do that. We'll take it to high speed tap on that ECM motor. The normally closed contact on the relay, we're going to swing over and we're going to select a speed tap on the motor itself. We're going to select a speed tap to give us 100% cooling airflow. And as a quick reminder, we always want to make sure that we set up our ductwork and we have our nominal airflow at 400 CFM per ton. 400 CFM per ton is our normal nominal airflow this is designed for. So if we've got a 3-ton unit setting outside, that means we're going to have to set up our ductwork and set up this airflow tap for 100% cooling airflow And if it's a 3-ton unit, as an example, that would be 1,200 CFM on this normally closed contact on a 3-ton unit for 100% airflow. The normally open contact on the relay is going to go, and we're going to select a speed tap on the motor to provide 60 to 65% airflow. So if you do some quick math in your head, or if you take your calculator out, you're going to find out that 60% of 1,200 CFM is going to be about 720 CFM. I had a contractor comment the other day, he told me, well, when we hook up to that normally open contact, that's 60%, but I don't have, or there's not they didn't have the capability of hitting exactly 720, and that happens on the ECM motor, on the AE air handler. And so the comment was, or the idea was, is that what if I'm at 650, or what if I'm at 675? Well, that's close enough. So the point I'm making is that you want to get close to about 60 to 65%. And let's say, as an example, speed tap number 3, I'm just making this up. Let's say speed tap number 3 gave me 675 CFM, and we're looking for 720 in my example. And speed tap number 4 gave me 840 CFM. Which one would I pick? Well, I'd pick the one that's closest to the 720. In this example, it'd be like speed tap number 3 as an example. So we always want to make sure that our contractors understand, our customers understand when they set these up. They're going to have to measure the airflow. We want 100% airflow on the normally closed contact of the relay, and we want to select a speed tap on the normally open contact of the relay for about 60% airflow. Any questions or comments on how we're wiring that relay up and selecting speed taps for different points of airflow on the unit? Any questions or comments on that?
No, we're good.
Okay. Well, please remember that S1 is our airflow reduction circuit. So when we get, let me do that animation again. Look at the relay. When I switch that relay, I'm generating an S1 signal outside, which is actually an airflow reduction signal. So the outdoor unit's making intelligent decisions. And when it starts modulating down, around that 60, 65, 50, 55%, whatever point of modulation, it's going to generate an S1 signal to energize that relay and slow the fan down inside to better match the airflow in that reduced capacity. Please note also that if we do have a W1 call during that S1 input from the outdoor unit, that airflow reduction input, if we do have a W1 call or a heating call, even on straight cooling, if the heat strip comes on, auxiliary heat for some reason, and the outdoor unit is operating in the heating mode of operation, let me take that back, that'd be a heat pump only application. But if we do have a reduced airflow and we do get an auxiliary heat call for some reason, it's going to ignore that S1 input, and it's going to drive the fan to 100% heating airflow, or more specifically, whatever speed tap, that high speed tap that we selected for heating. So anytime we get an auxiliary heat call, we're going to drive that fan to the high speed. Okay, let's talk a little bit about the heat pump of the variable speed air handler. We've got some other little things to consider with the variable speed air handler. The first thing we're going to talk about is during our simplified block wiring diagram. I wanted everyone to note that on the HMH7, the outdoor functions, we're going to be talking about the HMH outdoor functions, and we're not going to cover like the Hume terminal or the EAC terminals on the variable speed air handler, because they have nothing to do with outside. So those terminals that we are not using for the outdoor product on the simplified block diagram, we're not showing you. And again, some examples would be like the Hume terminal, the humidifier terminal, or the electronic air cleaner terminal. We're not going to discuss on the block diagram. Now, the wiring accessory relay kit number, HMH7AK 002 is required for this variable speed air handler. Now, this kit comes with 2 relays mounted on a board and are designated, the relays are designated RV and S1. Now, this kit is recommended for convenience and supplied parts, but let's go back for a second. What if you can't get a 002 kit? Oh my goodness, am I stuck? And the answer is absolutely not. All you would have to do instead of having the 002 kit is provide your own bi-flow filter dryer and then take two relays with 24-volt coils, single pole, double throw switching action. Mount those in the air handler, make up some field wiring, and you're going to be perfectly fine without the 002 kit. But the point is, we recommend the 002 kit in this application because it's convenient and it's got all the supplied parts, including the bi-flow filter dryer. And as a quick reminder, if you got a heat pump application, make sure that thermostat has that BO selection for reversing valve operation, because we're going to energize that B terminal in the heating mode. Okay, here's our block diagram for just an air handler, and we will talk about some straight cooling application or some straight cooling considerations here in a few minutes, but let's just go over this with a variable speed air handler and all the functions of the variable speed air handler in the heat pump application. So B terminal is going to go outside just like we had before to energize the reversing valve in the heating mode of operation. W2 is our second stage auxiliary heat. W1 is our first stage of auxiliary heat if you have a two-stage heat strip in there in the air handler. And that W1 is going to go outside as well to bring the heat strip on during defrost if you have a heat pump application outside. Y terminal goes all the way through like we did before. C terminal goes all the way through just like we did before. R terminal goes to the air handler and stops at the air handler because remember, Tame, we don't take R outside with the HMH7 heat pump. G is our 24-volt fan call. That's what you'd expect. And again, that's typical, just a green wire, is used very common in the industry for our fan call. Now, as we take a look at those two relays, remember, this is the 002 kit. But if you had two peanut relays mounted in there, it would do the same thing as long as they've got 24-volt coils. So on those relay coils, just take one side of the relay coils and take them both up to common and tie them together. So one side of the relay coils goes to common. On the S1 relay, we're going to take the other side of the relay coil and take it to that S1 on the outdoor unit. So that's going to be our airflow reduction relay. Common of the switching contacts on the S1 relay are going to go up to yellow, or the compressor call like we did before. Normally closed is going to go to Y/Y2. That's our high-speed airflow. Normally open contact on the S1 relay goes to Y1. That's our low-speed airflow. Now, where this is different on a variable speed air handler, the RV relay, all it's going to be doing is it's going to be providing 24 volts to the O terminal, or the orange wire on this AVC air handler. Now, this is really, really important. If you've got the air handler, a variable speed air handler, hooked up to a heat pump, you've got to tell it it's on a heat pump. Number one, there's a jumper selection that says heat pump or AC. You put it on heat pump. As soon as you put it on heat pump, the indoor air handler, the variable speed air handler, is looking for an O signal on the O terminal. And so what that is the air handler has to see an O signal in the cooling mode on a heat pump for some advanced functions, like dehumidification is one of them. Another advanced function is the cooling on delay function. So all that's driven by the O signal. So the RV relay, the other side of the RV relay coil goes up to B terminal. So when this unit's in the cooling mode of operation, you'll see that the normally closed contact and common is going to grab 24 volt off of yellow, just like we did before. But the normally closed contact on the RV relay is going up to O terminal. So look at this right now. So this unit's in the cooling mode of operation right now. We're calling for operation on the Y signal for compressor operation. It's on high speed on the airflow, and the B terminal that goes out to the reversing valve, the B terminal is not energized. So if you take a look at the RV relay, the normally closed contacts right now, we're feeding 24-volt power to the O signal or to the O terminal, and that is correct. So in the cooling mode of operation, the variable speed air handler has to have voltage on O on a heat pump application for some advanced functions. So this is our basic block wiring diagram on the variable speed air handler, but we'll do some animations here in a minute to show you how that switching relay works, those switching relays, and then we'll go ahead and talk about some straight cool applications. But before we do all that, is there any questions or comments on this block wiring right now that we've done with our two relays, the RV relay and the S1 relay on our variable speed air handler? Any questions or comments on how this is wired? We good?
We're good. We're good.
Okay. All right, so as we start taking a look at some advanced functions on this thing, let me do that animation one more time. So if we're calling for reduced airflow outside, what's going to happen, we're going to generate that S1 signal outside. It's going to switch the S1 relay, and we're going to command low speed or low airflow on Y1, or low airflow. Now, if we go into the heating mode of operation, watch this. Let me back up. If we go into the heating mode of operation, we're going to energize the B terminal on the heat pump for heating mode of operation, but we're also going to energize the coil of the RV relay. Watch this. Bang, right there. So when we energize the RV relay, what we're actually doing is we're breaking the 24 volts going to the O signal, and that's absolutely correct. So on a variable speed air handler, when we break the O signal, the air handler believes it's in the heating mode of operation, which is what we need. So in the heating mode of operation, we do not want voltage on O, because that O is going to be for cooling mode operation only on the heat pump. So any questions or comments on the relay logic, the relays, how they're working, how they're switching, how we're going to use those relays, the S1 relay for airflow reduction, the RV relay to make and break 24 volts to the O terminal on the variable speed air handler for advanced functions of that air handler. Any questions or comments on that?
No, we're good. No, we're good.
Okay. All right, so let's talk a little bit about cool only application with an AE air handler. So in a cool only application, we're going to tie in our heat strips, W1 and W2. We're not going to take anything outside. Your Y terminal is going to go straight outside. That'll be one of your wires outside. 24-volt common will go all the way through. And on your 24-volt heat cool thermostat, again, it doesn't have to be a heat pump thermostat. To a good earlier question we had, it doesn't have to be a heat pump thermostat, just a straight cool heat cool thermostat with 2 stages of heat, 1 stage of cool. R will go, again, just to the indoor unit like we had before, and G will be our fan call. Now, if you want to utilize on the AE air handler, the airflow reduction circuit, what we're going to do just like we did before. We're going to have that RV relay, or excuse me, the S1 relay. We're going to have that single pole double throw relay. We're going to hook the coil of that relay up to a 24-volt common and S1, the coil of the relay. We're going to have the common of the switching terminals, the common terminal for the switching contacts are going to be going to the yellow wire, just like we had before for compressor operation. And then again, because we want to make sure and drive that indoor fan to high speed anytime we have a heating call. So if the thermostat calls for heat, you know, maybe it's a mild day, maybe it's we heat in the morning and we cool in the afternoon. That can happen sometimes in certain parts of the country. So it's cool in the morning, we have heat on, then the thermostat calls for cooling operation. But anytime we call for heating, we're going to drive that indoor motor to high speed. Then on the normally closed contact, just like we had before on the normally closed contact, we're going to select 100% airflow on the ECM motor. And then on the normally closed contact, we're going to select 60 to 65% cooling airflow. So it's going to be wired just like we did before, except we're not going to be taking the B signal outside. And we're utilizing the thermostat to energize the heat strip. And we've got 3 wires outside. So if we've got a straight cool application with an AE air handler, with the airflow reduction capability, we're going to have 3 wires going outside.
So I got a question, man.
Sure.
So if we don't want to utilize the airflow reduction, we can leave it as a 2-wire by just having common and the compressor hooked up, right?
And I love that question. So let's say for instance, you're absolutely stuck with 2 wires outside and you just can't get another wire out there and whatnot. You can not worry about installing. You can not worry about installing that relay. And you see that yellow wire up there that that we're going to the common terminal on the relay. You can take that yellow wire for compressor operation and take it right over to your 100% airflow speed tap on your ECM motor, and eliminate that relay. You'd eliminate that relay altogether, but you take that yellow wire on the common terminal of the relay and just take it over to your 100% airflow on your ECM motor, and then you'd have 2 wires going outside. Now, let me caution you. If you do that, there's 2 things I want to stress. Be sure and put a bi-flow filter dryer on the liquid line because it's still a heat pump. It thinks it's a heat pump. In the outdoor unit, it may go into an exercise mode on the reversing valve to keep it fluid and to keep it moving and all that stuff. And so for 30 seconds or 15 seconds, you could have reverse flow on the refrigerant. So make sure you put a bi-flow filter dryer, even though it's on a straight cool application. The other thing to please consider when you're setting up your airflow, if you're in a humid environment, make sure that you consider anyway setting your airflow instead of 400 CFM per ton. I've already got approval from the factory, one of our factory engineers, to say what I'm about to say. If you are not going to use the airflow reduction on a 2-wire system and no relay, then what we're going to recommend you do is if you're in a humid environment, go ahead and reduce that airflow to 350 CFM per ton to give you a little bit more dehumidification during run cycle. And so we're going to always recommend that you have that S1 airflow reduction because that really gives you a wonderful level of comfort and all that. But if you're absolutely stuck with 2 wires and there's nothing you can do about it, then go ahead and reduce your airflow on the indoor fan to about 350 if you're in a humid environment. Otherwise, if it's not an issue, keep it at 100% cooling airflow at 400 CFM per ton. Excellent question. Any other good questions or comments? Everybody good? Okay. So if we have a variable speed air handler, and this is important, if we have a variable speed air handler, we're not going to take the B outside. And in the area of the control board itself, there's going to be a setting on a variable speed air handler. If you look in the area of the control board near the airflow settings, you're going to find a jumper that says AC and heat pump. Now, what I'm going to want you to do is even though it's a heat pump outside, we want to tell the air handler or trick it into thinking it's not a heat pump outside, it's straight cooling. So 2 things. Number 1, we're just going to have the single relay. This would be like like the 001 kit or just a single pole double throw relay that you mount in there and a bi-flow filter dryer. But go on the control board of the variable speed air handler up where find where the airflow settings are, the heat, cool, delay, and so on settings. And you're going to find a little jumper that says AC or heat pump. Move that jumper to AC. Now, what's going to happen if you do that in a straight cool application, when you move that jumper to AC on the air handler, it's going to ignore the O terminal. Let me say it one more time. When you move that jumper from heat pump to AC on the control board on the variable speed air handler, it's going to ignore the O signal. So now it just thinks it's on an air conditioner outside. Then after that, you're going to just wire it straight through, just a W2 to W2, W1 to W1. That's our auxiliary heat strip. 2-stage. If you have a 2-stage strip, the thermostat's going to control it all by itself, nothing to do with the outdoor unit. Y terminal is going to go straight outside, just like we had before. C terminal is going to go all the way through, 24 volt common. That 24 volt hot, that R terminal is going to go just to the air handler, and G will be our fan call, just like we had before. Now, this is going to give you airflow reduction on this variable speed air handler by taking the coil of that single pole double throw relay. One side of the coil goes to common, the other side goes up to S1. Now, if at all possible, especially with the variable speed air handler, you got this wonderful air handler. If you've got 3 or 4 wires outside, we definitely recommend having this airflow reduction because you're going to have some really wonderful comfort, especially with the variable speed air handler. The common of the relay is going to tie on to the compressor circuit, if you will, or the Y terminal from the thermostat outside, calling for compressor operation. That'll tie onto the common switching terminal of the relay. Normally closed will go up to Y/Y2, and the normally open on the relay will go up to Y1 for our reduced airflow. So again, anytime we have reduced airflow outside, it's going to drive that variable speed air handler to that low airflow on Y1. So we always recommend the relay if at all possible. But along with that really good question we had a minute ago, what if I'm stuck with 2 wires? If I only have 2 wires outside and I don't use the S1 circuit, what do I do, or what's going to happen? Well, the truth about it is, you're on the variable speed air handler, you can make some tweaks on the airflow adjustments on the control board. And we're going to recommend strongly that you set that up at 400 CFM per ton, and then go to where they call the delay jumper, and then set it for like a humid environment if it's humid outside, or if you're in a humid part of the country. So you can actually do some things with a variable speed air handler that you cannot do with an AE air handler, as far as tweaking your airflow to give you more comfortable dehumidification on the air handler itself. So the variable speed air handler is a really, really super good matchup with the outdoor unit, especially in straight cooling application. And without the relay, if you actually have a situation where you're not going to use that relay for airflow reduction. So 3 wires minimum going outside if you want airflow reduction, 2 wires if you're not going to do the airflow reduction, if you're just stuck with 2 wires. But please remember, one more time, even on straight cooling, please put that bi-flow filter dryer on that liquid line, because if you get in a situation where the unit is exercising that reversing valve or going into the heating mode just real quick to return oil and all that kind of stuff, we want to make sure and have that bi-flow filter dryer on there by all means. Any questions or comments on how we're hooking up a variable speed air handler and some considerations with that AC and heat pump jumper and the low voltage wiring that we've just talked about? Any questions or comments?
No.
Everybody good? Okay. Team, at this time, let's talk a little bit about airflow considerations. There's a couple things, again, I want to stress with that. The first thing is, please remember on every install to confirm proper airflow. The HMH7 is a modulating unit, and nominal airflow is going to be critical. And we're going to ask that all ductwork be sized to provide 400 CFM per ton of total cooling on the ductwork side. Now, on a straight cool application, it's recommended to utilize the S1 wire from the outdoor unit for reduced airflow. That's our standard recommendation. However, if S1 is not used, please consider reducing the airflow to 350 CFM per ton as a recommendation per ton of cooling capacity to enhance that humidity control if you're in a humid environment. So it's perfectly fine to reduce your airflow down to 350. We're going to design our ductwork for 400 CFM per ton. But if you got a little humid environment, there's some things you can do by reducing your airflow down to 350. I've already talked to some factory engineers. It's okay to do that. And so once you commission it and you set your airflow up and you got your ductwork properly sized and all that, if you need to back off your airflow a little bit to 350, you're perfectly fine to do that if you need some enhanced or a little extra humidity control. And then finally, we want to make sure that everyone consider manual D as our is our airflow and duct design criteria. And let's make sure that we don't exceed that recommended duct velocity in our main trunks and our branch runs and all that kind of stuff, because it's important that we have the air going across those heat exchangers on the indoor coil at the proper velocity as well. Some examples would be, for instance, on a main trunk, Manual D recommend. This is right out of Manual D. This is a table out of Manual D, the velocity table. And so our main trunk on the supply, we need to be looking for around 700, not to exceed 900. And if you've got a return trunk, 600 is recommended, not to exceed 700. On your branch runs, your takeoffs, the Manual D recommends 600 feet a minute velocity, not to exceed 700, and on the return 400, not to exceed 600, and so on. So you'll see that the Manual D, this velocity table, we ask that when you're designing the duct system to be sure and look at that. Registers and grills are all about the same. 500 feet a minute recommended on supply, 400 feet a minute recommended on return on grills and registers and diffusers. But this is a really big one, especially down in Florida and Mobile, Alabama, where I live. And, along the Gulf Coast, it seems like there's a lot of homes that have a single big return or maybe two returns with filters in the returns, in the return grill. So if you have a filter in the return grill, make sure that we design that return grill to be large enough to provide a maximum recommended velocity of 300 feet a minute velocity across that filter grill. So if you've got a filter grill with a filter in it, we want to make sure we don't exceed about 300 feet a minute velocity across that filter. That's right out of Manual D. So with all that, let's go ahead and open up the floor for some final questions and comments. As a matter of fact, I'm going to go ahead and get out of the PowerPoint at this point and bring my camera back on. And so we can open up the floor for a second or two for any final questions or comments for the day as we head towards the end of our training session. So what do you guys have for questions for me?
We really don't have any questions. I mean, it's kind of, it's a lot more or a lot less complicated than I thought it was going to be to go ahead and switch it from a heat pump to a straight cool.
And thank you for saying that. One of the things that we've been talking about with engineering and stuff is how could we apply this for straight cool application? And the consensus is don't hook up the B wire, don't take W outside, and all that, but be sure and put a biflow filter dryer on there so that if it does switch over, with some normal functions of exercising the reversing valve and stuff like that, that we don't end up having a refrigerant fault because of it. So be sure and put that biflow dryer on there, even though it's straight cool application, and don't take those other wires outside. And there's no reason that the thing just won't work perfectly in a straight cool application as well.
So I'm having a training at my house with some contractors, and we're going to do this. So we're going to hook it up as a straight cool. We're going to run it for a little while. Then we're going to hook it up as a heat pump. So they're kind of going to get a chance to see both applications.
Man, that's a great idea. I think that's a good idea. Keep Tony and I posted on your progress on that. We'd love to hear your field experience and what you're running into and what you like about it and all that.
Yeah, we'll do.
There's no, so regardless of whether or not if you hook it up in straight cool with 2-wire or 3-wire to get the added airflow, thermostat, does it need to be in that particular situation just a single stage, one heat, one cool thermostat?
That's a really good question. So what you're going to do is on your thermostat, you're going to decide on the front end how many stages of heat strip you're going to have. If you've only got a single stage heat strip, then single stage heat, single stage cool thermostat, but you're going to want to make sure and go to that thermostat, and there's going to be a switch on there that says gas or heat or electric. Make sure it's on electric, because we want to make sure and bring the fan on anytime we have a heat strip call.
But now if you're using it in its regular wiring operation, you're using a 2-stage because it's a heat pump and a backup heat strip, so you'd use a 2-stage thermostat.
That is correct. So if you're going to be doing something like a heat pump thermostat, make sure that you've got enough stages of heat for. So you'll have B for your first stage of heat, and then you'll have another stage for your auxiliary heat. That's correct.
You mean you really just can't overkill this? I mean, it's just.
I'm glad you said that instead of me. The truth about it is one of the things I really, really like about this product is it's simple to wire up. Even with all the functions on a variable speed air handler, you still only have 5 wires going outside for everything. And if you have a situation where you just have straight cooling application, you only have 3 wires going outside, where you still have your airflow reduction on your relay. So yeah, it's very, very simple. And the cool thing about it is all that mojo happening outside. Mojo, by the way, that's a technical term, right? All that mojo outside on the compressor and the modulating and all that is from a single input on that yellow wire saying, hey, we want compressor operation. So you don't have to have a multi-stage cooling thermostat and all that. You just have a single yellow wire out there, and the compressor and all the smarts out there takes care of itself. I really like that.
Well, we appreciate your help, Joel. Thank you, sir.
Absolutely.
When will the video be available, Joel, so I can get it emailed out to some guys?
We're going to let me go ahead and stop the recording right now. And